This is how you can easily do direct and inverse proportion questions for iGCSE maths. Starting off with some direct proportion questions, whenever you get a question that says directly proportional, like t is directly proportional to the cube of r, you always have to use y is equal to kx, okay? And it doesn't necessarily have to be y and x. In this case, it's t and r cubed because it tells you to the cube of r. But how would you put it in to this formula, right? So instead of this y, we'll have t because it tells you that t is directly proportional to the cube of r cubed. So you wouldn't just put r cubed, you would put k r cubed. K is our constant. These two are variables. So remember, this k won't change, but the y and x can be whatever it tells you in the question. So it actually tells us that t is equal to 21.76 when r is equal to 4. If we substitute both these values in, so 21.76 for t and 4 for r, we can actually find k. So let's just do this. Let's put in 21.76 for t, and we'll put in and 4 for r, and we have r cubed, so don't forget the cube. 64k. Divide both sides by 64. We have k is equal to 21.76 over 64. This can also be rewritten as 17 over 50 if you put it in your calculator. So now that we know that k is equal to 17 over 50, what we can do is actually rewrite our formula. So originally it was t k r cubed, but since we know our k, we can rewrite it as t is equal to 17 over 50, which is our k value, which we just found out, r cubed. It's asking us to work out the value of t when r is equal to 6. We have to substitute that in like so and cube it. Then if you put this in your calculator, you should get 73.44. Now for this one, we have y is directly proportional to the square of x. When x is equal to 3, y is equal to 36. Find the value of y when x is equal to 5. Again, directly proportional, so it's y is equal to kx. But we have our y being our y and square of x for our x. So y is equal to kx squared. When x is equal to 3, y is equal to 36. Plug these values in. So 36 for y, and we have 3 squared. We can rewrite this as 36 equal to 9k. And our k is equal to 36 over 9. So our k is equal to 4. Now that we know our k is equal to 4, we would just rewrite this formula and put 4 for k. So y is equal to 4x squared. And it's asking us to find the value of y when x is equal to 5. So we know that x is equal to 5, so it'll be 4 times 5 squared. 5 squared is 25, so 25 times 4 is just 100. And that's our answer. So we have x squared is directly proportional to y. X is equal to 25 when y is equal to 3. Find x when y is 9. Again, direct proportions, so we use y is equal to kx. In this case, we have x squared being directly proportional. So instead of this y, we would put x squared is equal to k. What is directly proportional to? Y. So ky. X is equal to 25 when y is 3. So instead of the x, we put 25 squared equal to k. Well, what is our y? Our y is our 3. So just 3k. 25 squared is 625. And this is equal to 3k. So we divide both sides by 3 to get rid of this 3 here. So we can get k alone. So k is equal to 625 divided by 3. So now that we know our k, we can rewrite our formula. X squared is equal to 625 over 3y Now it's asking us to find x when y is equal to 9. Well, we know that our y is equal to 9, so we can substitute 9 for y, like so. So 9 is being multiplied by 625 over 3. If you put that in your calculator, you should get x squared is equal to 1875. To get rid of the square, you'd square root, and you have to square root both sides, so you'd end up getting x is equal to square root 1875, same as 25 root 3. A is directly proportional to 4b. A is equal to 12 when b is equal to 5. Find b when a is 42. Again, direct proportion, so y is equal to kx. This is very important. Our y here is a, since a is directly proportional to 4b. We could just rewrite this as 4bk. So a is equal to 4bk. It tells us also that a is equal to 12 when b is equal to 5. We can substitute both these values in to find our k. So we have 12 is equal to 4 times 5k. 4 times 5 is 20, so it's 20k. And divide both sides by 20 to get k is equal to 12 over 20, which is just the same thing as writing 3 over 5 if you simplify this. So we have our k value, 3 over 5. We can rewrite our equation of a. If we substitute 3 over 5 for k, we will have a is equal to 4b 3 over 5, since we know the k. So we have a is equal to 12 over 5b as our new formula. It's asking us to find b when a is equal to 42. Well, we know that a is equal to 42, so we put that in for a, make it equal to 12 over 5b. This b is currently being multiplied by 12 over 5. We reverse it, we divide it by 12 over 5, and what we do to one side, we must do to the other. So b is equal to 42 divided by 12 over 5. So once you put that in your calculator, you should get 35 over 2, which is the same thing as 17.5. On to some inverse proportion questions. So whenever we have anything which is inversely proportional to something else, you would always do y is equal to k over x as opposed to y is equal to kx. And of course, it doesn't have to be y and x, as I mentioned before. In this case, it's actually p and m. So it says that p is inversely proportionate to m. So this is our formula. It also tells us that p is equal to 48 when m is equal to 9, and to find p when m is equal to 12. Well, we know that p is 48, m is 9, so k over 9. We just substituted in the values, as you can see, and multiply both sides by 9, so that we can find out what k is. So 432 is equal to k. Again, once we found out our k, all we need to do is just make our new equation, and instead of this k, we just put the value, which is 432 over m. And now that it's asking us to find p when m is equal to 12, all we have to do is just substitute this 12 for m. So p is equal to 432 over 12, which is also just rewritten as 36 if simplified. Now for this one, we have t is inversely proportional to d squared, and t is equal to 12 when d is equal to 8. Well, let's make our formula first. We have t is inversely, so k over what? K over d squared. It might also say the square of d, which is basically the same thing as d squared. And again, it tells us that t is equal to 12 when d is equal to 8. Just substitute those values in. So 12 for t and 8 for d. 8 squared is 64, so k over 64. And multiply both sides by 64. 64 times 12 is equal to 768. So again, our k is equal to 768. We rewrite the formula, substituting in our k, and it's asking us to find t when d is equal to 0.5. Easy, just substitute in 0.5 for d. 0.5 squared. And if you put this in your calculator, you should just get 3072. Now for some more inverse proportion questions, it's just going to be the same thing. Y is equal to k over x. Q is inversely proportional to the square of t when t is equal to 4, q is equal to 8.5. Let's first formula. Q is inversely proportional, so k over square of t, so it's the same thing as t squared. When t is equal to 4, q is equal to 8.5. Let's plug in those values. 8.5 for t, and this is equal to k over 4 squared. So 8.5 is equal to k over 16. Multiply both sides by 16, and you would get k is equal to 136. Again, once we know our k, we just rewrite the formula. And now we're being asked to find q when t is equal to 5. So q is equal to 136. What is t equal to 5? So we put 5 squared. So 136 over 25, which can be rewritten as 5.44. Now y is inverse proportional to x cubed. Y is 40 when x is 9. Find a formula linking x and y. This is essentially just asking us to find our formula, but also find what k is. First, we need to write out our formula with k. Y is inversely proportional, so k over x cubed. Right? How do we find out our k? Well, we're given that y is 40 when x is 9. So if we plug both those values in, that's 40 k over 9 cubed. Same thing as k over 729. We have 40 is equal to k over 729. If you multiply both sides by 729, you'd get k alone. 40 times 729, 29,160. Again, once we have our k value, which is 29,160, all we need to do is just rewrite our formula, putting in our k value that we just found out, and that is literally just it. We found our formula linking x and y, meaning we have x and y in it, and we found our k. Now pause the video and answer these questions.